We have some vocabulary terms we're going to go over today. Use the bottom of page 14 of your guided notes to jot these terms down. Now, the first term is the Tyndall Effect. Now, for all these terms today, I have video demonstrations for you. So to better understand these, please make sure you watch the video demos. It'll make things much more clear, so to speak, as you try to learn what these terms are and how they relate to this unit. The Tyndall effect is the reflection of light off of suspended particles in a mixture. Sometimes it's hard to tell whether a mixture is homogeneous or heterogeneous. Let me draw a picture for you. And once again, this picture is not nearly as nice as what you're going to see in the video. If I have a solution, we have one phase. So if I were to shine a light, this will be a laser beam, kiddos, at this beaker, the beam from the laser you would not be able to see as it moved through a solution, because there are no particles for it to reflect off of. It's sort of kind of like shining a laser beam in a room, just a classroom. In your room, there's no particles for that beam to reflect off of, so you really can't see the beam. You just see a dot on the wall. However, if you put smoke in that room or if it were foggy outside, you could actually see the beam. Your room air is a solution. It's one phase. This beaker here is a solution. It's one phase. We cannot see the light reflecting off of suspended particles like we could if it were a smoke-filled room or a foggy room. Likewise, if I had a beaker that contained a suspension of very, very small particles, and I shine the beam through it, that beam could actually be visible inside that beaker. And when we see the beam, we call that a positive Tyndall effect. That means the mixture that we're looking at, kiddos, is a suspension and not a solution. There must be something suspended in here for that beam of light to reflect off of. It must be cloudy, so to speak. But sometimes these mixtures, you really can't see the cloudiness with the naked eye. You need to have a beam of light shining through that to detect that there are particles indeed suspended in there. Okay, that's the Tyndall effect. Once again, the video demonstration I have for you hopefully would clear up any questions you have related to what that is. The second term for the day is called distillation. Now, distillation is the separation of the components of a mixture by differences in boiling point. Oh, that's supposed to say in boiling point. Let's make that look a bit prettier. In boiling points. Let me draw a picture of a beaker here, and in this beaker, let's have water, and let's put some sodium chloride, some table salt in there. You all know that when you put salt in water, the salt dissolves in the water. It can't be filtered. We can't separate the water from the salt by filtration. However, what if I were to put some heat to this beaker? What if I were to put it over a stove top or a Bunsen burner flame and get it really hot? Wouldn't the water begin to boil and turn into a gas? Well, the sodium chloride, its boiling point is much higher than water's boiling point. It would stay inside the beaker. So we could separate the water component of this mixture from the salt component due to their differences in boiling point. You can imagine if I let this boil all day, wouldn't I be left with a beaker at the end of the day with just some crusty table salt in the bottom of it and all the water will have left? Yeah, well, that's called distillation. In the lab, we use distilled water. We do not use tap water. In the demonstration video that I have for you, I take tap water and we boil it and we separate the water component of tap water from all the other stuff that's dissolved in it. We collect the steam and recondense it. When we recondense it, we collect it drop by drop, and we end up with pure distilled water that we can use in the laboratory. We don't use tap water in the laboratory because, believe it or not, there are things dissolved in the tap water that we don't want to be part of our experiment. So distillation is your second term for today. The last term is something called chromatography. Now, there's a couple of different types of chromatography. Chromatography is the separation of the components of a mixture but this time it's by differences in molecular weight or differences in the ability to dissolve in a solvent. Now, once again, you really need to watch the video demonstration for this, because when I draw a picture here, it's going to be a lot more difficult to understand what's happening than when I do a video demonstration for you. So let me change this color. Let's go to, I don't know, something that is green, shall we? Let's say I have a piece of filter paper, and on the bottom of that piece of filter paper I take a green dot of water with a water-soluble marker. Just put a nice little green dot there, nice and dark. And then I set this piece of filter paper up in a beaker with a little bit of water at the bottom. Won't the water begin to wick up the paper? It'll move up the paper. And when it does, won't it come in contact with that green dye? Well, green, you guys know, has blue dye in it, and that's right, yellow mixed together. Well, these guys dissolve in the solvent, water, differently than each other. They also have different molecular weights. Therefore, the blue and the yellow dyes will move up the paper at different speeds. So, as we let this paper sit in the water and the water begins to wick up, we will get a separation of the blue dye that makes up my green dot and the yellow dye. And we will see two different colors on my filter paper. We might have blue that might be up at the top and yellow that might be lower, or vice versa, depending upon their solubility, their ability to dissolve in the solvent, and their molecular weights. That's called chromatography, and that's the ability to separate the components of a mixture by differences in molecular weights or the ability to dissolve in a solvent. Once again, for all of these, you need to watch the videos to get a better understanding of what I'm talking about here. And then I think you'll feel better about it. Okay? All right. Talk to you guys soon.